Students World channel. So today we will be doing a lesson regarding physical quantities, which is a chapter of physics. So okay, it's basically physics. So let's begin with it. Okay. So there are two type of physical quantities. Let me draw. So first are like fundamental, or we can say the basic ones, the basic physical quantities, and the other are the derived one. So the derived ones are basically the one are made up of, means they consist of the fundamental, but the difference is fundamental quantities are of means you can say they are pure. They don't, they are only singular, they are only one. But derived quantities are like uh, the product or the ratio of two basic quantities, the basic or fundamental, you can say. So I'm here writing basic in bracket, we can also call it basic. Okay, so this is what it is. Okay. Okay, so let me just give you an example of fundamental. An example of fundamental can be um length, and breadth, we can say length, breadth, and corresponding to it will be derived, can be area. And as we all know that area is the product of L into B, which is length into breadth. Okay, so this is how it works. Fundamental is just one quantity, a pure kind of, you can say, but the derived ones are like the ratio or product of uh, two or more than we can quantity. Okay, so okay, um, all right. So the next is uh, so these two quantities are further divided. So there are two kind of fundamental and derived quantities, which are known as scalar and vector. Okay, so basically scalar quantities are are completely specified with the magnitude and SI unit, and it doesn't need any direction. For example, the example which I mentioned earlier is like length and speed, time. So it doesn't need any direction. Time doesn't need any direction. Speed doesn't need any direction. Okay, so the vector are completely specified with their magnitude, SI unit, and as well as direction. It means the difference between scalar and vector is just of direction. Okay, so an example of a vector quantity can be like momentum, velocity. Let me write it: momentum, velocity, and velocity and torque. Uh, okay, so this is how it works. It means we can just differentiate between scalar and vector like this, that the um the quantity which requires a direction is known as vector, and which doesn't require a direction is known as scalar. And rest of the definition is same, that they both are specified with the magnitude and SI unit. Okay, so now I'm going to just give uh, a brief review over the prefixes which we can use to define these physical quantities. uh, okay, so basically prefixes are just used to simplify or reduce the paperwork, like the calculations, rather than writing. I hope that most of you know what are indices. So these prefixes are basically like standard form or indices, whatever you can say. like you must have studied in indices the standard form in which let me just write it here, in which the number should be less than should be greater than 0 but less than 10, like that, into 10x, like this. I hope you have done that. And okay, so let me just draw the table. So there are two types of prefixes, like for larger quantities there are different prefixes, and for smaller quantities, smaller than like centi, milli, those quantities, for those quantities they are different. Okay, so okay, let me just draw the table. It might take some time, I hope. Okay, so I will also tell you the symbols through which we denote these quantities. Okay, so okay, uh, one more line please. Yeah, okay, so it's I'm just going to copy it for my next table. Okay, okay, let's start with it. So basically these are the prefixes, and these are the symbol, and this is the value of those prefixes. Okay, so let me start with the smallest first. The smallest is Pico. Uh, Wait a minute, please. Use Pico. So it is denoted by a symbol P, and its value is 10 power minus 12. So it is the smallest one. Okay. Then we have Nano, and it is denoted by an N simply, and its value is 10 power minus 9. The third one is micro, and its symbol is a bit different. It's like this. Yes, it's like this, and its value is 10 power minus 6. So basically you may notice that the difference is of 3. Okay, so next one is milli. Milli is denoted by a simple m, and its value is 10 power minus 3. The last but not the least is centi, and it is simply denoted by c, and its value is 10 power minus 2. Okay, so okay, let me draw another table in which I will give the value give the prefixes of greater values. So I've got another table which I copied earlier. Okay, okay, so it's fine here. Let me take another color. Let's take this or this. Okay, so here it is. So again I will mark here prefixes, symbol, and the value. Okay, So here I will be starting from the smallest again. So the first one is a kilo, which is represented by a small k, the lowercase letter, and its value is 10 power 3. Then I have mega, and it is denoted by a capital and uppercase M, and its value is 10 power 6. The next one I have is giga, and it is represented by a capital and uppercase G, and its value is 10 power 9. And the last but not the least, I have tera, T-E-R-A, tera, and it is denoted by an uppercase T, and its value is 10 power 12. So this is the way the prefixes, as I told you before, are used to mention the higher or the lower values of the physical quantities. Um, so it is just basically used to simplify it, and uh, I hope you all know the indices, so it will be easier for you to learn it. Okay then. So here we will just let me give you an example of prefix being used down here. So maybe you know or you will learn it later on. The speed of light is also denoted using the speed of light. It is also used. It is also denoted by these prefixes, which is 3 into 10 power 8, and as it is the speed, so its SI unit will be meter per second, but the latest one is like now this is meter per second, but the latest one is uh, ms minus 1. So they both are same, whether you write meter per second or ms minus 1, it means the same. So this works like this. Okay. So I hope this was an informative session for you all, and I hope it give you an basic idea of what are the physical quantities and the prefixes we use to denote their values. So I hope will help you in your studies, and uh, I think that it's time for me to sign off. Then uh, we'll meet you in the next video with new subjects, new topics, and everything new. So please do like, share, and subscribe the channel, and do press the bell icon for the latest updates. Thank you.